All right, morning everyone. So what we are going to do today, we're finally going to do some pure. Okay, so we've done all the stats, not just for year one, for year two as well. So you will learn no new statistics topics. However, we will next year go back over some. So that's why it's important that you keep doing these exam questions to get better. But we're moving back into pure, and this is pure handbook 10, all about sequences and series. So we'll start with sequences. And sequence is just a list of numbers defined by a specific rule. You might have remembered this from GCSE as when you looked at nth terms. The terms of a sequence are often expressed as U1, U2, U3, with U1 being the first term, U2 being the second term, etc. An arithmetic progression is a sequence that progresses arithmetically, i.e. that the difference between the consecutive terms, so going from one to the next, is constant. Okay, it's always the same. So if we take a sequence like 5, 7, 9, 11, we can notice here that the common difference is always 2. And the same with 4 positive 1 minus 2 minus 5. We always are subtracting 3 to go to the next term. So with these sequences, the first term we refer to as A. Okay, that's going to be important in a second. Okay, so this first term referred to as A, and this common difference, the amount that we have to add or subtract to get to the next term every time, is going to be D. Okay, so 5, 7, 9, 11 is a arithmetic sequence. If it went 5, 7, 10, 14, that's not an arithmetic sequence. Okay, we'd be adding 2, then 3, then 4. There's not a common difference. And also, say we had 1, 3, 9, 27, 81. We're multiplying by 3 each time. That's not an arithmetic sequence. That's what we call a geometric sequence, which we'll look at later this week. So the formula for the nth term of the arithmetic sequence, so if you want to find, for example, the 27th term of the sequence, then you replace n here with 27. So we want to use this rule. Okay, and this we need to learn because it's not in the formula book. Okay, so to find any term of the sequence, we use A, which is the first term, and then we add on n minus 1 times D, which is the common difference. Okay, so if you can imagine, if you have to add 2 each time, then you just have to add on how many lots of 2 from your first term. But we do n minus 1, of course, because the second term, we only need to add 1 lot of 2 on to our first term. So in terms of our arithmetic sequence, it will go A, which is the first term, A plus D, which will be the second term, so A plus your common difference, and so on. So let's do a few examples where we're using some of these rules. Now the first one, we've got the nth term of the arithmetic sequence is un equals 55 minus 2n. Write down the first 5 terms of the sequence. So very simply, I'll just check on questions. Nope. Okay. So the first term of the sequence, we just simply substitute n equals 1 to find out what u1 is. So the first term of the sequence is just when I put in n equals 1, I get 53. To find the second term, I just put n is 2. So 55 minus 2 times 2, 51. So u3 is 49, u4 is 47, and u5 is 45. Okay, you can very quickly see that we're simply, our first term is 53, and then we're just taking away 2 each time. Okay, I could just write that as a list as well if I wanted to, but I want to get used to this new notation. So the first question for the chat then, part B, find the 99th term of this sequence. So what is going to be the 99th term of this sequence? So you might want your calculators for this. Or change yourself, do it in your heads. Okay, Tilly, Dominica, Mia, Grace, all saying minus 143. Fantastic. Okay, all we simply do is just sub in n equals 99, and we can find that 99th term. Okay, so it'll just be minus 143. Okay, and you can see by using that nth term, it's certainly quicker than had we just kept on taking away 2 from the previous term. And then finally, find the first negative term in the sequence. So there's a couple of different ways we can go about it. We could set it up as an inequality, but I'm going to keep this nice and simple and just simply set it equal to 0 and then find out what value of n would give us 0. So we solve this equation and we get n is 27.5. Now obviously n can't be 27.5, can't have 27.5th term. So we simply just round that to 28. So I want to substitute in 28. I'll do 55 minus 2 times 28. So the first negative term is minus 1. We probably could have guessed it was going to be minus 1 anyway, just because these are all odd numbers. So the first negative odd number you'll come to is minus 1. But this is just kind of, sometimes you might need to find what n is. So this is the method that you could use, okay? Obviously, we take n as the 20. Obviously, we want to round up here because the sequence is going down. So 27.5 gives you 0. So if you want to get into negative numbers, you're going to need to round up. Okay, if you put in n equals 27, it'll give you positive 1. Right, if you have any questions, let me know in the chat. Yeah, well done, Sharon as well. Minus 143, fantastic. So example 2, if you've looked at notes beforehand, just know that it should be the 17th term. There's a little mistake in the notes for this one. As just be aware of that if that hasn't been changed. So example 2, find the 17th term of the arithmetic sequence as follows. So what we need to do here is look at this sequence, and I can see that my first term, A, is just going to be 12. D, the common difference is minus 3. That sign is really important. Okay, if you put it's positive 3, your sequence is going to be going up. If you put it's negative 3, sequence is going to be descending. So n is 17. I'm looking for the 17th term. So I want to use this formula that I introduced at the start. Okay, I certainly just don't want to start at 12 and keep subtracting 3 until I get to my 17th term. I want to try and find quicker ways of doing this. So 17th term, or U17, I just sub in A as 12, I put in N as 17, and I put D as minus 3. Work that all out, and we simply get our 17th term as minus 36. So our next question, we've got a sequence here that goes 11, 15, 19, all the way up to 643. What I'm going to do now is see how many terms there are in that sequence. Okay, so to do that, well, what do I know about this sequence? I know that A is 11, my first term. D is 4, the common difference. Okay, it's going up by 4 each time. And the last term in the sequence is 643. Okay, so I know that UN is 643, but I want to find out what N is. So in that formula, so yet again, I use UN equals A plus N minus 1 times D. Really important, we've got to learn this. Okay, got to learn this. UN is going to be 643. A is going to be 11. N is what I'm trying to find. And I know that D is 4. So then I can simply just rearrange this. I'm going to take away the 11 from both sides, divide by 4, add the 1, and I get 159. Okay, and I could go back and sub that back in, check it. If I do 11 plus 159 minus 1 times 4, I should get 643. So there's 159 terms in that sequence. Again, I'm just going to quickly check any questions that we have. Please do put them in here. Also, later when you're doing some of these questions, just please put the questions in the P10 channel, because as I put in my post earlier, sometimes the questions that you have might be questions that other people have as well. Okay, so we're just going to do examples 4 and 5. Little bit of a shorter one today than perhaps some of the other ones, but give you more time to have a practice at the end. So example 4, a sequence is generated by the formula un equals an plus b, where a and b are constants that we're going to find. We're given the information that u3 equals 5 and u8 equals 20, and we've got values. We've got to find the values of the constants a and b. So I don't necessarily want you just to put the answers in chat, but can anyone give me a strategy? Anyone give me a method of how I would approach this? Or even just a certain technique that I might use? Okay, so I have one suggestion to solve them simultaneously. Okay, so that's a really good idea, because we essentially have, in this we've got quite a lot of unknowns, but basically in our original formula we've got 4 unknowns, but we can sub in 2 pieces of information, which just leaves us with 2 unknowns. So remember, we've got 2 equations, 2 unknowns. Let's just get in there and solve them simultaneously. So firstly, if I know that u3 equals 5, that means 5 is the 3rd term, okay? Remember that subscript number there, that 3, that is your n term, okay? So when the term 5 is the 3rd term in the sequence, okay? I don't know a and I don't know b here. u8 equals 20, which means the 8th term in the sequence is 20. So when you've got 20 there, you've got n as 8. So if I call this equation 1 and this equation 2, what I can just do is 2 take away 1. And I'll just solve that to get that a is going to be 3. And then just simply substitute a equals 3 into either equation. So I've just put it back in equation 1. 3 times 3 for 9. 5 take 9. It leaves us with b as -4. You can solve simultaneous equations on your calculator, but to be fair, I think it's quicker to do that one without going on your calculator. You can see it's quite a quick one to solve. And then finally, example 5, the 3rd term in the arithmetic sequence is 13 and the 6th term is 25. Find the common difference and the 1st term. So yet again, we're going to use un equals a plus n minus 1 times d. And the 3rd term is 13, so that means we've got, when n is 3, un is going to be, u3 is going to be 13. So just be careful here. Remember, when we set up we find any term sequence, we use n minus 1 in that bracket. So make sure you do 3 take away 1 there for the 2. And then for the 6th term, we do 6 minus 1, so we just put an n as 6 there. And we've got our 2 equations. So just be careful. The 3rd term, you're going to have 2d. The 6th term, you're going to have 5d. It might be tempting to think you're going to have 3d and 6d there. So just be aware of that. I then just do equation 2, take away equation 1. You can do it other ways, but it's probably the quickest way. And we simply just get d as 4. And then when we substitute d in, we just simply get a as 5 there. Okay, so really this is just an introduction, just getting you used to sequences. I didn't want to go on to the sum of the sequences today, just because I think it'd be a bit too much if I did that as well. But hopefully this gives you a lot of time just to practice catching up on anything that you've missed from previous weeks. And I'll post something a little bit later about start questions. Tomorrow, we're going to see if you are better at maths than a 7-year-old. Okay, so stay tuned for that for tomorrow. And just to do a quick recap of today then. So the really important thing I've mentioned it all lesson, but just using that nth term to find any term in the sequence, un equals a plus n minus 1 times d, where a is your first term, d is your common difference. So bear that in mind when you're doing these questions today. Have a go at these ones. The ones we want to see are 4, 7, 9, but make sure you do all of them. They're relatively short questions, some of these ones today, so don't be too overwhelmed by the fact there's 8 questions there to do all together. Have a go at them all. Don't just do the ones for the assignment. Just make sure you do them all. If there's any questions, let me know. I'm going to stop the recording here. But please let me know if there's any questions.